Hi, I'm Rob, and I'd like to welcome you to the next video in the AI on AWS playlist on the Cumulus Cycles channel. In this video, we'll look at an insurance claim submission app which uses Amazon Comprehend, Textract, Rekognition, Translate, and Poly to process submitted text, images, and PDF files. Now, before we get started, I want to mention that this video is a continuation of the prior AWS purpose-built AI services video in which we looked at several AWS AI services both in the console as well as in a Jupyter notebook to make API calls. If you're not familiar with these services or how to make simple API calls, you may want to check that video out first before continuing here. Okay, with that out of the way, let's get started. Now, as with the last video, I'll provide a link to the GitHub repo with the code in the description below. In this video, we'll be focusing on the _purpose-built AI services demo apps folder, and specifically the insurance claim submission folder. As previously mentioned, this app uses Amazon Textract, Comprehend, Rekognition, Translate, and Poly to process submitted text, images, and PDF files for an insurance claim submission. The tech stack for the app consists of a React front-end and a fast API backend, which uses the Python Boto 3 SDK to communicate with the AWS services. Now let's jump into Cursor and take a closer look. I'll go into the Insurance Claim Submission Project folder, and because this is a full stack app, we have both a backend folder and a front-end folder, as well as a root.env file in which we'll place our AWS config credentials. You can copy the .env.example file and save it as a .env file, then update accordingly. Specifically, you want to update your AWS region, which I'll be using US East 1, add your AWS access key ID and secret access key, and create an S3 bucket which Textract will use for processing, and provide the bucket name here. I'll quickly do this off camera so we can launch the app and take a look before diving into the code. Okay, with my .env file updated, I've opened the app's README and scrolled down to the setup section. First, we see some prereqs. You'll obviously need Python, and I'm using the UV package manager, but feel free to use whichever package manager you're comfortable with. And we'll also need Node installed for npm for the React app. Looking at the backend setup, I'll go ahead and open that folder in a terminal, then activate my UV virtual environment, and although I've already installed the dependencies, I'll go ahead and do that again here. We've already taken care of our .env file, so I'll go ahead and launch the app, which you see is running on port 8000. So I'll jump to the browser, and we see our claim processing API docs. And if we expand the process claim API, we can try out processing a claim by submitting the claim description text, an accident photo, and insurance forms, which will send these documents to the AWS services and provide a response. So let's go ahead and try it out. First, I'll attach the claim description text, which I know you can't really read, but we'll see the full text in the response. Then attach the accident image and the rest of the insurance forms. Now I'll execute. And when the response returns, we see we have some data on the claim we submitted. When we get into the front end, we'll get a detailed look at the response, so let's go ahead and do that now. So back in Cursor for the front end setup, I'll open that folder in a terminal. Now I've already run npm install, but you should go ahead and do that, then execute npm run dev to launch the app, which we see is running on port 3000. So I'll load that in the browser, and we see our user interface for submitting a claim. Now, again, I'll start by providing the claim description text, then the accident photo, and the remaining insurance docs, then submit the claim. And when the response comes back, we see the pane on the right has the JSON response data, which we can look through. It contains each service call's response for each asset submitted in the claim process. And if we scroll down on the page, we see detailed output for each document. Here we see the claim description text has a neutral sentiment determined by comprehend, and it's been converted to speech by Poly. Scrolling down, we see the accident pick now has bounding boxes, and we see analysis for the other claim documents as well. Now, as I previously mentioned, the tech stack used to build this app consists of a fast API backend with a React frontend. Of course, you can use any frontend you want, so I'm not going to dive deep into the code, since this isn't a video on front-end app development. But here's the code in the API TypeScript file, which sends the user-provided claim data to the backend, then returns the response to the app.tsx file to display the results on the page. Alright, now let's shift our attention to the fast API backend. This application follows a service-oriented architecture, where each AWS AI service is wrapped in its own service class. The main fast API endpoint orchestrates these services to process the insurance claims. But before we look at the specific services, we'll start with the main Python file. As expected, we see quite a few imports up front. We see the imports for the services, and we're importing from config. And if we look at the config file, we see it loads the .env file, does the AWS configuration setup with the values we set in the env file, adds server configuration, and the core's origins. It has properties for file upload configuration, AWS service limits, where to place the static files when they're downloaded, sets the default voice for Poly, and provides service feature flags to enable or disable API calls, and finally configures logging. Scrolling down, we see we instantiate an instance of Fast API, configure core's middleware, and then mount the static directory to store the downloaded audio files. We have the health check route, and then utility functions for the API service calls. The main processing starts in the process claim route, which processes the claim with the user provided data and translates the results. Now, I'm not going to walk through all the code in this app. Instead, I'll focus on the process claim function, which is the process claim endpoint the front end hits when the user submits a claim, and of course the AWS AI services integration. So let's start with the Fast API decorator that registers the function as a post endpoint, and specifically the response model. The response model is a pydantic model that defines the response structure. The endpoint returns a processing result instance, and Fast API serializes it to JSON matching the schema. The response model processing result parameter tells Fast API to validate the response against this model, which we see here in the response_models.py file. There's a processing results class, which has an instance of the claim description result class and a file result class. And the file result class has instances of the Textract result, Rekognition result, comprehend result, and Poly result. Now, let's move on to the function signature, starting with the request parameters. The request is sent from the client as multi-part form data, which means it includes both text fields and uploaded files. First, we have a claim description. This is a required text field where the user explains what happened in their own words. Fast API treats this as standard form data and ensures it's provided before the request is processed. Next, we accept an accident photo. This is a required image upload and is a single photo of the damaged vehicle or scene. The image is later used for visual analysis, such as detecting damage on objects using services like Amazon Rekognition. The request also supports insurance forms. These are one or more uploaded files, in our case usually PDFs or PNG images. Fast API allows us to accept multiple files at once, and these documents are processed for text and structure using services like Textract. Now, let's talk about dependency injection. This endpoint relies on several back-end services, and Fast API's depend feature is used to inject them automatically. We inject a Textract service for document analysis, a comprehend service for natural language processing, a translate service for language translation, a Poly service for text-to-speech, and a Rekognition service for image analysis. Each of these services is created through a getService function, which handles configuration and lifecycle management. So putting it all together, here's how the flow works. Fast API first parses the incoming multi-part request, separating the text fields from the uploaded files. At the same time, it resolves and injects all the required service dependencies. By the time the endpoint logic runs, we've already validated user input and fully initialized service clients. Now, looking at the processing logic in the function, we see a call to the comprehend service detect language function, which takes the claim description. Expanding the services folder and opening the comprehend service Python file, we see the Boto3 SDK is imported, which, as we've seen in prior videos in the playlist, is used to make the call to the AWS services. When an instance of the comprehend service is instantiated, a comprehend Boto3 client is created. The detect language function is the function called from main, and it calls the private detect language sync function, which calls the detect dominant language function on the comprehend client, passing it the text. It then returns the language code and score, which is returned to the calling function and stored in the language result. The rest of the service integrations follow a similar pattern, so I won't go through all of them. For instance, in the translate service, we see the translate Boto3 clients instantiated, and the translate text method is called on the client, passing the text, the source language, and the target language. For Poly, we instantiate an instance of the Poly Boto3 client and call synthesize speech, passing it the text, the output format, the voice ID, and the engine. So that concludes this video walkthrough of the insurance claim submission app, which uses AWS purpose-built AI services for processing user-submitted insurance text, images, and PDF files. However, as it stands, everything is running on our local machine. In the next video, we're taking this to the cloud. I'll show you how to host your React frontend in S3, create a serverless fast API backend with API Gateway and Lambda, and wire it all together with Amazon Comprehend and Rekognition so users can submit claims from anywhere. Thanks for watching.